With that, we welcome our speaker tonight, Sunile from Elastic, who are also kind enough to sponsor the food tonight, because that's a thing, right? I mean, we're a community, right? Microsoft lets us use the room. It's very nice of them. We like that. But we need help with the food and speakers. And yep. So tonight it's Elastic. Thank you to Elastic, and thank you for Sunile for speaking. Sunile, over to you, sir.
Very good. Okay. Wow, this is. You want to turn that down a little bit? Is there an echo?
Right. It's kind of loud. Yeah. Yeah.
We're gonna go rap.
Speakers, Sunile. Speakers. Oh. Okay. Stand back. Stand back.
Stand back here. That's the best place to see him.
Trust by that.
Okay.
Still.
We're gonna go rap.
Never mind. Manage with that. Okay. Just project the noise. The nearest microphones are in the. Oh yeah, I meant to say this. For those of you in the room, the room is mic'd for those online. So even if you're in the back, you have microphones over your head. So top tip: private conversations at the back, quietly amongst each other. It is not private. So you're mic'd. So FYI, green means we'll turn them off later. So yeah, so
the mics.
The green are the mics. So yes, project to those.
Okay.
They can hear you online.
Okay. Perfect. So I assume folks online, just let us know if you cannot hear me or my voice is not projecting it up. I'm Sunile Manjee. I'm a senior principal architect, a search AI expert at Elastic. My background is I started in the Apache community. Those of you that know Apache, it's an open source community. Started off as an Apache Spark engineer, and then I moved on to Apache NiFi and Flink, and I spent some time in Kafka, but I didn't really enjoy it. So I went back to NiFi, which is really one of the most fun projects in the Apache land to be a part of. I joined Elastic about I joined Elastic around a little less than 3 years ago. And the reason why I did it, because I'm upset, I have an unhealthy obsession with AI, and large language models was something I wanted to learn. So about 12 months ago, I was a part of a team with Cambridge, and we built a large language model. Those of you, I don't know if everyone knows what a large language model is, but if you're using ChatGPT.
I don't know what a large language model is. No idea. Could you tell us?
Yes. So large language model is, it's built, oh my God, I have a whole deck around this. I do a keynote around this. So large language model is basically, if you work with ChatGPT, it's one of the model types. Okay. It's called the completions endpoint. And basically you can have a dialogue with data. You can have a dialogue with a machine, and what backs that machine is a model. And that model was based on the transformer framework. The transformer framework, the reason why the transformer framework is very interesting, those of you have heard of neural networks, convolutional neural networks, recurrent neural networks. And the reason why those didn't succeed, and again, that's a adversarial stance with some people, but I'm okay with that. Recurrent neural networks, the problem with recurrent neural networks was that it was a feed forward layer, but it had to bring over everything it remembered. So think about having a conversation with each other. Every time you talk to a person, you have to regurgitate everything you know about them and then learn something new. And then you meet them again, regurgitate that entire damn conversation and learn something new. So it was very expensive computationally. So it really didn't take off, but for short text, really well. Convolutional neural networks was really good because they talked about the pixelation and looked at 3x3s and 2x2 boxes for oftentimes looking at images. But it really wasn't meant for text. And so there's an individual in India, I forgot his name, but he basically changed the world. He basically said, what if? He wrote an abstract called Attention is All You Need. And basically he said, what if we created a model that behaves like a human? And what his thesis was that, what if our conversations, like what you're hearing me talk today, and about 2 to 3 days from now, you'll probably remember a fraction of what I said, which is okay. But there's certain parts of this conversation you may pay attention to, and it's going to be your neurons that activate that. And the next time, hopefully we get to see each other, you're going to say, oh, you're the guy that said X. right? And something like that. So there's some attention activation. So instead of, by the way, reoccurrent, there's also LSTM, long short-term memory models. Why did they not take off? So he talks in his abstract about that LSTM models, long short-term memory models, are about what you should forget. And that's not very human-like. Sometimes it is. Sometimes you walk into a conversation like, damn, I don't want to remember that. But most of the time it is, wow, I learned something, I want to continue forward. And that's what attention is all you need. So a large language model is based on the transformer network, and models are built off of that. And I was a part of a team at Cambridge that we open sourced a model. It was called Silver Retriever. It was for academic purposes, but it ended up becoming a very competitive model. We spent around $4.5 to $5 million. It wasn't my money, but it was $4.5, $5 million. And we were a large team of 36 individuals. I joined it only because I was very curious. I wanted to learn about how a model behaves. Why does a model behave? Because when you ask ChatGPT a question, you have to wonder, how the hell did it come up with the answer?
Okay.
And so the easiest way I describe that is that if I say, may the force, what do you think you're going to say after that? What completes that? May the force. The reason why he said that, what's your name?
Ray.
Ray. The reason why Ray said that is because you probably have watched Star Wars, right? So something in your training data set has the completion, may the force be with you. Now, there may be some young folks in here that may not have seen Star Wars, and so they can't complete that sentence. So some models are not smart enough to answer the question. The reason why they can't do it is because their training data set just doesn't have enough information. Now, the newer models, for example, the Gemini models, and there's a new type of model that Google is building, and they believe that they don't need to have the answer anymore. You don't need to train a model anymore to understand and have all this training. They believe that just like a human, we learn new things constantly. That's a challenge with the model today, is that if you ask it a current question, like who is the president of the United States, it may more than likely say Biden, because it was trained 3 months ago or 6 months ago. They get stale very quickly. It doesn't have context around what you're asking. So Google believes that they've created something new. Now, Google does a lot of this, where they think they've created something new and then they abandon it. And I don't mean to be disrespectful, but it's a part of their history, right? They're very innovative and then they abandon a lot. So they believe that they've created a new model type. I forgot the model. I'll tell you if I can find it in my notes. But they created a new model type that basically says, you don't need to train anymore. We'll train it. And then as you have conversations with it, you'll start to remember in a database, in its own database, start to remember new conversations, learn new context. I don't agree with that because we don't have a database. I believe that models should behave like humans, and we don't have a database. We have memory, we forget. So I believe that we have to come up with a better way. That is a large language model. Sorry, that was long. Answer the question. Okay, so let me explain our large language model and how do we overcome lack of context? Because if you ask a large language model, who's the president of the United States, it will answer Joe Biden because it doesn't have the recent history. So we use a vector database to go and handle that. Now, it doesn't have in this room has never played with the vector database or does not know. It doesn't have. If you do know, I'm going to skip right past that stuff, right? So I'm here for you. I speak about this stuff on keynotes all the time, so I'm here for you. So okay, so let me explain. By the way, everything I talk about today, it's going to be available to you for free on locally. So you can put this on your laptop. If you want to play, you want to learn, you can go to that website on the bottom. It's ela.st local-elastic. You get a local Elasticsearch instance. It's a vector database. It doesn't have. I will explain what a vector database is. Yes.
Will this presentation by chance be available too?
It doesn't have. Yeah. Yeah. We're an open source company, so all our decks are.
Yeah, we'll post the link on the Meetup site. I'll work with you up.
Very good. Very good. Yeah. There's a couple other links I'm going to share with you about.
How many pictures I need to take?
Yeah. Yeah. Good question. There's a couple other links about educationally where you can go to learn more about a lot of stuff I'm talking about. Okay. A lot of it is free. So let me explain. And by the way, this is just maybe a little architecture, but those of you that are from the enterprise, you're like, I don't want to do this on my laptop. We do offer our Elastic vector database in the cloud. It's serverless. You can do it in Kubernetes. So just get that out of the way. You can get it wherever you are, right?
So
So
for you using containers or anything on Microsoft DevOps or anything, would it be available in there?
it
That
doesn't
was
have,
hard to hear. Sorry.
Didn't hear that. Could you repeat the question?
So if we're using containers or any type of VMs in Microsoft Teams or anything like that in Microsoft DevOps, would the vector database be available in there?
it doesn't have for me to
Do you
understand.
have any containers or
Yes, so
that they can deploy DevOps?
okay, yes. So Elastic, go back here. So Elastic is available first on Azure, okay, on the Azure market. So we deploy on Azure natively. This is an Azure Meetup, so we do that naturally. We also offer it on Kubernetes. So we have Helm charts. We have YAMLs for if you're not a big fan of Helm, I don't know why you wouldn't be. And then we also have containerized. So if you're like, hey, I have Docker machine, it doesn't have old school, so I highly be careful with that. But we do have containerized instances as well. What I was showing you here is you get a containerized instance on your laptop with all the machine learning and AI capabilities I'm going to talk about today. You get that on your laptop. Will it be slightly slow? Yeah, because you don't have a lot of compute, but you can do almost anything I want to talk about today. Did that answer your question? Let me know if I did not answer your question, all right? It doesn't have.
No, that answered the question perfectly.
Oh, no, nothing's wrong with Docker. I'm saying Docker Enterprise and running that instead of running it on Kubernetes. I think the industry has spoken. I don't think I'm saying anything that's profound. Kubernetes is the deployment model of choice on-prem. It's not Docker Enterprise. Docker is a container. Docker Enterprise tried to compete with Kubernetes, and anyone that tries to compete with Kubernetes is probably not going to have a long life because Kubernetes has a massive community behind it. Right? So I don't think that's adversarial in any way. What is your level of experience with Elastic? I just want to know. I think some people said they don't. Zero, don't even know what Elastic is. Okay, so we'll start from the beginning. No big deal. What's your level of, I think I've already asked this, vector search, vector databases, and then RAG, retrieval augmented generation. Zero, like, I don't know what that is. And anyone actually deployed a RAG app? Yeah. So you know what's interesting about that? 6 to 8 months ago, I asked that question. Nobody would raise their hand. Now, when I'm asking the question, about 20 to 30% of the audience does. So, you know, you ever seen the chart, like the sea of delusions in terms of like when does a technology actually become real? Yeah, exactly. So it's starting. It's starting because a year ago, everyone just wanted to learn. Now people are actually deploying. In fact, I'll show you a couple of examples of that. Okay, so what are we? Before we get into some of the tech, is we're a search engine. We're a search database. And you store data in it. You can connect to data sources like any data source you have. And we're going to do that. If you want to do some of what I'm going to talk about today, you can do everything I'm going to talk about today on your laptop. So let's say you have a PDF file or you have data in S3 or, excuse me, Azure, anywhere your data is, you want to connect to it. So we have a connector framework. And then once data's in, you want to ask questions. The only requirement to use this is curiosity. So if you don't have curiosity, this is not a good database for you. Okay? And once data's in, you're going to start to use ML and AI. I'll explain some of those components to you in just a moment. And then lastly, we have observability. So once you're an enterprise architect, you deploy this amazing application in production that's search enabled. Let's say you want to find hotels, whatever search application your heart can think of, you deployed it, and then you're like, I want to observe it. So we have an observability suite around that. And then lastly, we also provide a SIM. We are an open source solution, okay? One of the few out there still that's completely open source. And everything we do, we don't sell you these things. We don't sell you search. We don't sell you observability. We sell you this is it. This is what we are a part of. Okay, so how you use Elastic, you get all of it out of the box. So when you download it on your machine and you're like, hey, I want to see if I deploy a search application, what if it goes down? Does this Elastic tell me? Yes, it tells you out of the box. Okay, it's a comprehensive search solution. So let me explain how AI has changed us and our behavior. So about 2 years ago, we were totally okay with asking questions on Google or Bing and receiving links. That was totally acceptable. And the burden of understanding and reasoning was on us. And those of you that are engineers in this room probably use Stack Overflow like me, Python, right? Stack Overflow is huge. We had to learn and he's nodding his head. So he's probably seen all the BS of all the bad comments of people that were trying to be helpful. And then there's a jackass that says, you're wrong. Like, dude, chill. We were just trying to help each other. We're a community. We have to sift through that BS. The burden of reasoning through that BS is on us. Now that burden has shifted to the large language model. The burden of reasoning through layers of understanding of links and data has shifted. So now we no longer want a link, we want an answer. That is the world we live in. Okay. And again, we may be technical here, but my wife is a nurse, and it's very interesting that she works for Memorial Hermann here. And she's even saying that based on what she's seeing in the Epic systems, that when you come into the hospital at Memorial Hermann, you have a chart. Why can't we just have a conversation about the history of when you've been at Memorial Hermann? Why does a nurse or a doctor have to sift through paperwork, tons of paperwork to figure out you have a history of, heart issues? Why can't you just ask the question, like, tell me the 5 things that I should be aware of the history of this patient? The amount of time it takes a machine to do that versus a doctor, significantly different. Right? Doctor, they could be more efficient in the ER. There's many applicable use cases. I'll show you this today of where a large language model can augment our work. Sometimes it will replace it. This is not Terminator, but it is going to reason and understand. Well, let me give you one cool example of a customer I worked with. They wanted to enable chat with video. So oftentimes when you think about a search website, you think about Google and whatever powers that. But also think about searching upon anything that you can think of. You think about searching on PDFs, think about searching on videos, think about searching on images, think about searching on audio files. So what if we could do that? What if we live in a world where there's video data and you can just simply ask. Just a moment. Let me turn this off. I realized that was going to come out. Just see if I can turn off my video. Okay, bear with me. I don't know if I can stop sharing for a moment. If I can stop audio, this will be not working. All right.
You need help?
I don't know. I'm a jelly.
You're a Zoom guy.
I'm a Zoom guy. I don't know how to turn off my audio. Do you know how to do that yet?
I think I muted you.
Your mic is muted.
So you,
But then my speaker, when I turn my speakers on, just on me.
one of your speakers on.
Sorry, I'm not there. There you go. There you go.
Yeah.
Let me send it to Phil's system that we talk here.
Yeah, you speakers need to be on.
Yeah, that's what I was going to show them on the video.
Oh, you're going to serve the sound?
Yeah,
Okay.
the sound from there. So I don't know if I can rejoin or would like to.
Try rejoining.
Okay. I'll be right back.
Oops.
Wait,
Yes, and I made that mistake. Yeah. Join audio. Let's go. All right, go back.
get back.
All right, I'm back.
So I think if you do include sound, I think that will, if you want to play a video, I think.
See if this works. Okay, we're good. We should be good.
All
Let's see how loud this is. All right, so let's take an example of asking a question, chronic leukemia survival rates. Now, there's a couple of folks that talked about what is the new survival rate, and what if I just want to find the answer to the question, but it's not necessarily in a document, it's in video. So let's ask the question.
Asking.
And you can see here that the video is 7 minutes long. Hopefully you can see this, I think so. The video is 7 minutes long. I'm lazy. I don't want you to give me a link. Remember, we're no longer taking links. We want answers to questions. And here, what we did is not only did we find the answer to all the videos that we stored, but we also found exactly where in the video is the answer. So let's take a look. Before,
I will just give you one example. In past, chronic myeloid leukemia was considered a deadly disease. Before, when we didn't have the targeted therapy, the 5-year survival rate for people with chronic myeloid leukemia was only 22%. Today, the overall 5-year survival rate is 90%, which...
There you go. So listen to that video later. But my point here is that we, as a society, demand that not only do we get generative answers, but when we are searching on video data, we have become so lazy that we want you to just point us exactly to what the answer is, which is okay. We can demand that. So that's an example. If anybody's wondering, how did we do something like that? We used Azure Cognitive Service, okay, to go take the video data, take the transcript, and then we also use the Whisper SDK. And the Whisper SDK basically takes the voice and translates that into a vector. Don't worry if you don't know what that is. I'll explain what vectors are. And we also look at, there's multiple people in the video, right? One of the challenges of doing something like this is when there's multiple people in the video, how do you know who's saying what? So we do that. We vectorize the data, and then we also look at the voice in this Whisper, where we see the differentiation of individuals speaking, and we label that. We don't know who the individual's name is, but we say person 1, person 2, and then we can relabel that later on. So now you can specifically say, if I knew her name, I could say, hey, you know, when this person said something, that's what I want to know. Right? Think about a meeting of like 40 people in it. You're like, you know what? I only want to know when Sunile said something about AI. Right? Because that would be important.
asking,
So retrieval augmented generation. Remember I talked to you about if you go to a large language model today, you ask it, who is the president of the United States? It's going to give you, possibly give you Joe Biden, depends on which model, unless the model uses an agentic workflow, which we'll talk about in a moment. So how do you overcome something like this? And it's called RAG, retrieval augmented generation. So we're still using the large language models like Gemini or OpenAI or Azure OpenAI models. But what we're doing is we're augmenting that with answers. So if I ask a question, each one of us works somewhere. And if I ask the question to OpenAI today or Azure OpenAI, how many vacation days do I get as an employee working here or my company, wherever you work? If I'm an employee for 2 years, how many vacation days do I get? The large language model would say, I'm not sure. I don't even know where the hell you work. Okay. But what if we found the information about your how many days you get vacation or whether you get MLK day off, whatever your policy is? What if we found that information, gave that to ChatGPT, and then ChatGPT would say, oh, you know what? You've been here an employee at Elastic for 2 years. You get 3 weeks off. Okay. We're making the large language model more intelligent. That's why it's called retrieval augmented generation. This is what an application looks like. By the way, this is a customer, this is a deployment of a customer that we had to obfuscate. And don't get overwhelmed by this. There's a lot here within the architecture, but I'll go through it very quickly. When you ask a question, you need to find the answer, and the answer is often in a vector database. And we'll explain what that is in just a moment, so bear with me, just keep putting a pin in that. But once you ask a question, you see all these charts here. I know it might be hard to see, but there's an aspect of asking a question, understanding it, reasoning through it. And I'll give you one example of where reasoning matters. I'm working on a use case right now with the largest telecommunications company on the planet. And they're asking, when there's a question about my iPhone is not charging, they want a bot to encounter that and answer the question. Now, what is the challenge with that question? iPhone is not charging. Anyone want to guess?
What model iPhone do you have?
Hey, you're on it. He's on the money. It's ambiguous. What the hell does that mean? Like iPhone's not charging. You may have 5 iPhones, right? You may have 10 iPhones in your family. You might have an Android, so at least that's out of the equation, right? The model can, the agentic workflow can say, okay, I can figure this out. So there's ambiguity detection. You're too ambiguous. So there's nothing wrong with the bot saying, hold up, I see that you have 3 iPhones. There's a 13, 16, and a 10. Which one is not charging? And then you supply say, oh, my 16 is not charging. And then now the bot could say, I know what to do, and continue asking questions. So think of this chart as a reasoning layer to set, how do we find the right answer? think about when somebody asks you a question. I know we take it for granted. If you're an expert in technology or whatever you're an expert in, if I ask you a question, you give me the answer immediately. But remember, there's all these neurons that connected together immediately and reasoned, and then they found the answer. That's exactly what a model's doing. Okay.
ASCII.
So there's also a challenge that some of these models are expensive. And when you ask a question over and over again, if you have kids, you probably know what this is. They keep asking, do you like my hat? The answer is, I do not like the hat. Well, this happens in retrieval augmented generation as well, is that when you ask a question, let's say I ask a question, let's say we work in the same company, and I ask a question, do I get MLK day off? And let's say somebody else asks the same question, but they say it a little bit differently. Is MLK day off for me? Those questions are similar, right? They're not different. But what happens is when you ask this question, you go to the vector database, you get the answer. Yes, you get an MLK day off, but we have to go back to the large language model and give it the context. But the questions were pretty damn similar. So we do something called LLM caching, where we see if we've seen this question before and we reason through that and we say, you know what, we're just going to give you the cache response. You get MLK a day off. We don't even need to go to large.
ASCII.
So let me give you an example of curiosity. So I am obsessed with the FOMC because I find that if you, by the way, these are people that control our lives. It's the Federal Open Market Committee, right? They dictate almost everything we do in terms of how we're going to financially be good or bad. And if you read their meeting notes, I know most of us, and I'm not saying most, maybe you do what I do, but many of us just go to TV and listen, oh, rates going down. You go, good. But if you actually go to the meeting notes, they say so much that you can tell, and it's totally legal. Okay, I'm not telling you to do this, what I do, but I listen to them very carefully, and I decide how I'm going to trade on my ETFs. Because there's a lot of ETFs, and again, I'm not giving you advice. I'm just telling you what Sunile does, is that I like to pay attention. And I listen to who is a dissent, who dissents, who does not dissent. What is the consensus on the rate? So let me give you an example of how you use a vector database with Elastic to just ask questions as long as you have curiosity. So we're going to do this live together.
ASCII.
We'll do this one right here. Let me move this little controller here. So this is the FOMC meeting notes.
ASCII.
Public information.
Yeah, FOMC is public. Yeah, Federal Open Markets Committee. This is on, in fact, if you just go here, FOMC meeting minutes,
ASCII.
Fed,
ASCII.
and
ASCII.
here you go. Here's the meeting minutes. Okay, I look at this all the time. Okay, and it's just because I'm hyper obsessed with what's going to happen with our money, right? Or my money at least. So I look at this stuff, and look at this. They tell us on the news, they tell us this much, the rate's going down. But there's pages and pages of amazing information here that can dictate what's going to happen in the future. Should you buy your new car now, or should you just wait a few months? And there's so much that can impact us. So let's take an example of data. This is Elasticsearch. This is our UI. And let's say we take that PDF file
ASCII.
and we just give it to Elastic. Here's the
ASCII.
meeting minutes. It's the PDF file, and I'm going to add it. I'm going to just ingest it into Elastic, and I'm going to call it FOMC Azure.
ASCII.
And I'm going to change something here.
ASCII.
Bear with me. Since
ASCII.
we are talking about vectors and AI, what we're going to do in this scenario is I'm going to ingest the PDF file, the meeting notes, and
ASCII.
I'm going to vectorize this content. And I'm going to chunk it. So those of you that don't understand what that means, don't worry. But if some of you did Raga, but chunking and vectorization is something I want to talk about. But a large language model only has so much context it can handle. So you have to give it chunks of information. Put a pin in that for a moment. So we're going to automatically send a PDF file, and we're going to automatically chunk it. And oh, by the way, since this is an Azure Meetup, we're going to use the Azure embedding model.
ASCII.
Let me explain what that is. Just a moment. So Azure has all most of the AI models that you can think of. They have, I think they ended up adding Mistral as well. But in this scenario, the most popular one is ADA002, which is an embedding model. It's basically a model that takes text and converts it into numbers. I'll explain what that means in just a moment. I keep saying that. I'm sorry. I apologize. I should have started with that first. I recognize I love talking to you. So let's take this example. I'm going to call Azure real time, and I'm just going to give it the text Batman or Superman, and it converted it into a numerical representation.
ASCII,
Those of you that remember linear algebra, matrix multiplication, that's what this is. It's just an embedding model. Okay. Now, the reason why this is very interesting for those of you that may not be familiar is that if you want to remember, I told you the previous example. Do I give Martha MLK day off, or is MLK day off for me, or whatever you want to say? How do you compare those two sentences? The
ASCII.
similarity. Well, yeah, you can create a bunch of Python scripts and try to see if text is similar. You know how hard that is? What we do is instead we just convert everything to numbers. And once those are numbers, guess what you can do? Anything. Anything in life you can convert to a number. Now you can do math operations against. That's it.
ASCII,
Right? When clinical trials, what do you think they're doing when they can go through pharmaceutical clinical trials? Do you think they're just looking at your reaction? No, it's not just your reaction, it's your age, your height, your weight. Everything about you is now a math figure, it's a dimension, and they compare the dimensionality to everything else. That's what we're doing here. We're converting everything to numbers.
A quick question.
Yes,
So, I hear about tokens. Are these tokens?
I'll explain that. So that's good. Let's actually address that now. Tokens,
ASCII,
a model,
ASCII,
it uses a token terminology. And a token is basically, think of it like vocabulary. When you train a model on the Wikipedia data set, think about your children. How about that? We'll use your children. I have a 9-year-old child. There's certain terminology that she doesn't understand yet.
ASCII,
Now, my 13-year-old kid, he has a much larger grammar, much larger language, vocabulary. So based on the model, if you give it data or words, it's going to take each word and token it. That's a token. Each word is a token, but not every word
ASCII,
is a token based on how the model has been built. So I'll give you an example. If the model does not understand the word, it will split it into two different tokens. Because think of it like a 9-year-old child or a 5-year-old child that does not understand the vocabulary. They just jumble it up. They turn it up. But the 13-year-old that has a large vocabulary, they understand the word, that becomes a token. So why do tokens matter? You know who said the new currency of the world is going to be tokens is NVIDIA's CEO, Jensen. And the reason why he said that is everything we do in our lives in vectors and we do in large language models are now based on tokens. So that text I just gave you, Batman or Superman, more than likely, this is 3 tokens because the model ADA002 is incredibly smart. But if I gave it some interesting word, or let's say I made shit up, it would probably say, you know what, I'm going to split this into 2 tokens. I don't really understand. This is how Azure charges you. It's by tokens. This is 3 tokens. It's like 6 cents. It depends on the model. But here I just called it, right? So I just got charged probably 6 to 24 cents or 18 cents, excuse me, to run it against Azure. That's tokens. So you do a large language model, the amount of data you sent it gets converted to tokens, and you pay per token.
ASCII,
Good question. All right, so what we're going to do since we're at Azure Meetup is we're going to actually use Azure's model, this model that I just showed you, 002, and I'm going to ingest the PDF file. I'm going to throw it at Elasticsearch, and it's going to vectorize it. Yeah, it'll cost me maybe 50 cents to $1, but that's okay. If this works, it's PDF, and it's done. Now that we have thrown the FOMC data at Elastic and we vectorize it, now we can do some really cool things. So in Elastic, we have something called Playground. Now, what does Playground mean? It's exactly how this sounds. I can connect to a large language model. Here, I've connected to Azure OpenAI. Think about, this is, I believe this is the 4.0 model. You can connect to almost any model you want. You want Gemini, whatever you want to connect to. The reason why is I'm going to ask a question, and I don't want the link.
ASCII,
I want the answer.
Ask.
So let's see how this works. We're gonna ask a question
Asking.
of the
Asking.
data, and the data is here. It's in the FOMC. Remember I talked about that we ingested it into this index. And now I'm gonna ask a question. What stance did they take on the rates? Now, what if I ask this question in ChatGPT? It would have no idea. What the hell is they? Who's they? I like it would have no context. So what we did is I'm asking questions. We go find the answer to the question based on the data that I have in Elastic, and then I sent that to OpenAI or Azure OpenAI, and Azure OpenAI said, oh, they decided to decrease the rate by 25 basis points. But we humans are never satisfied with just a single question. So we're going to ask, this is what I say, do any members dissent? This is, by the way, this is a key indicator, in my opinion. I'm not giving you advice. This is Sunile just letting you know how I think. Is when there's a member that dissents, I have found a pattern that the likelihood of the rate staying the same is significantly high when there's a dissenting member. And I think they just announced that they may not decrease rates. Yesterday.
Yes.
Did they say that?
Yes.
Yeah, this is my little secret sauce. I'm not telling you how to trade. I'm not doing that at all. I'm just telling you, this is Sunile being weird, and I like to read the notes. But I use a vector database because, listen, those notes are pages and pages and pages, and a lot of legal crap that I don't understand. I'm not a legal expert. This model can understand that. So now I'll continue asking questions. So I know that the person dissented.
Asking.
And then I say, which indicators swayed the FOMC decisions? This is very interesting because this tells me that if I believe the rates are going to go up and down, I want to know, like, what do they think? What are they concerned about? Because if I personally think that, oh, this is not going to be a problem, if it's, egg prices are too high, well, they're going to come down at some point. So I'll make a decision that, you know what, we're good, we're fine. It'll come down at some point. And then what was the strongest economic symbol? A single. Why do I care? Because I want to know if they're like, oh, cars are selling really well, and that is the economic factor, we are screwed because that's not a good economic factor to base our decisions on. But why am I telling you this? I'm not giving you financial advice. I'm just having fun. I'm telling you that this is an example where you don't even, did you notice how I didn't talk about Python? I didn't talk about Java. I mean, this individual here, he knows Python very well. I'm sure he can wrap up an application very quickly. But the reality here is the only requirement in Elastic to use our database is curiosity. That's it. That's all it takes. Ask questions. Yes.
See, I mean, you would need a subscription, right, for Azure OpenAI.
Or you can use the free subscription to OpenAI. Right. So, okay, that's actually a good question. So a lot of enterprise customers who I work with, right, banks, large banks across the world, they all have a relationship with Azure or AWS or whoever it is. They all have it. But a lot of large banks, especially in the US, do not trust the cloud. Nothing against Azure. I love Azure. But they don't want to trust. They don't want to, like, notice I asked the question. That data is going to the large language model on Azure. A lot of banks don't want to do that. They don't want to send their data to Azure. So how do we overcome that? They're hosting Mistral, for example, is a very popular one. You can actually have Mistral on your laptop. There's a tool called LLM Studio, which is one of the more popular. You probably know about that. So I have it hosted on that, so I can host a large language model right on my laptop, and then I can have this connected to my laptop. Okay, so you do not need to have a subscription. You do not need to pay. It's pretty
Basically, what you're saying is the inferencing is happening locally on your laptop.
Okay. So remember when I ingest the document, the PDF document? When we ingested the PDF document, in my scenario, because we're at Azure Meetup, I called Azure OpenAI to do the inferencing, the embedding.
Yeah.
Right? You can call your local model like Mistral AI on your laptop, 100%.
Okay, so you can have the LLM locally on your laptop.
Absolutely.
Okay.
Absolutely. And the second part of it is, now that the data has been vectorized, this part right here, which is the OpenAI, where it's the one generating this response is generated by that model. That is a different type of model, right? The embedding model creates those numbers I showed you. This is like ChatGPT, where it's creating the text. the feedback, the human interpretation of it. That can also be another model that's hosted. Mistral is a multimodal model. So Mistral can do embeddings and Mistral can do completions. But some models, for example, like the mini LM V6, they only do one thing. They generate numeric representation of text. They don't have anything that does like completions. So some models are multimodal, some models are single.
ASCII,
Question online.
You want to talk about it? Would you need a strong GPU to run Mistral? It depends on the application. So if you're just having a science project, like most of the stuff I do, because I'm always doing research, you do not need it. That's in fact, I run Mistral on here. I have a MacBook and it doesn't have a really good GPU on it. So no, you do not. But for production grade applications, where you're going to find that you need a GPU is concurrency. CPUs just don't do a good job on high concurrency or inferencing.
ASCII,
Hopefully that
ASCII.
answered the question. You had a question?
Yeah, so if I understand you right, you need the LLM twice then essentially, once to ingest and then once again to query.
Is that so?
So, and do the models need to match? Like,
Nope.
does the ingestion model need to match the query model?
Ah, okay. I thought you were gonna ask something else. Good. So this model, it's a really good question. So you notice this text, Batman or Superman, that's a model, and I inferenced it. I turned it into numbers. Now, if I ask a question of this silly statement, I need to, let's say you ask a question, spell Superman. A silly
ASCII.
question. You can't just send that text to a vector database. You need to vectorize that. So let's take this example. Let's run with it for a moment, okay? So let's say that the data was something exactly like this. In
ASCII,
fact, we're going to vectorize something like Sunile loves Superman and his kids love Batman. Okay? And then let's say we inference that.
ASCII,
That's a number. Okay?
ASCII,
Now I can ask a question.
ASCII, ASCII, ASCII,
What character?
ASCII.
Character, because models are pretty darn smart. What character does Sunil
ASCII,
love?
ASCII,
So when you ask a question, you have to actually vectorize that question. Why? Because the numbers here
ASCII,
are now
ASCII.
going to be computed against the numbers against Sunil loves Superman and his kids love Batman. I'll explain that in a minute. Why that matters, because this is highly dimensional objects. So you remember when we learned about the X and Y coordinates many years ago? And then in third grade, we learned about the Z coordinate, third dimension, and our minds were like, wow, well, this is 1,500 dimensions. So
ASCII,
think about a highly dimensional space, and this number is not just 3 dimensions. It's 1, 2, 3. I think this is 1,500 dimensions. So now what we do is we take this number, put it in a highly dimensional space out here, 1,500 dimensions. Sunil loves Superman and his kids love Batman. That's where it is in a highly vector space. And then now we ask the question, what character, I say char, does Sunil love? And what we're doing is we're saying, hey, in a highly vector space, it's going to be very close. We're going to go
ASCII.
grab this answer. And that's the answer. You may find multiple.
ASCII.
I'll explain that in a moment. But that is a vector. Remember, everything you can convert into numbers, now you can do computation. So when you say Sunil loves Superman and his kids love Batman, and then you ask a question, what character does Sunil like? We will do a distance calculation between these two objects. We will do cosine, dot product, L2 norm, any of them. Okay, Euclidean,
ASCII, ASCII,
axial product. It's a lot. Yes.
I had a question. When you were ingesting, it was a question about whether to use semantic for that. I don't know, I guess
So
something of.
ASCII,
So you're asking,
So I was wondering what the difference is, because I know there's semantic, there's hybrid, and I was wondering.
Let me show you that. Let me show you that just a moment. The semantic is this. So how we enable semantic search is by taking text, converting it into a numeric representation, and then
ASCII.
giving you proximity.
You can determine if it's close or not, or how close it is based on taking the square root of the sum of the squares of the differences of each of the elements in the vector.
Yeah, we calculate, like, in fact, we just see if I can bring this up here. Oh, it's not. So let me give you a very simple example of how this works. If I gave you, if you're looking for a F-150, you expect an F-150, right? On a search result.
ASCII,
What if I say pickup truck?
ASCII,
What's
ASCII,
your expectation? Silverado, F-150, Ram 1500. Why? Because now we opened it up for semantic interpretation. How the hell does the engine know that a pickup truck is an F-150 or a Ram 1500? It's because when you go in a highly dimensional space and you convert pickup truck into a number, it's going to drop itself here. And then F-150 is going to be here, 1500, Tundra.
ASCII,
And then we grab all the objects that are near it, and then that's what you get. It's magical. It isn't, it's math. And how do you
ASCII.
compute the distance between a Ford F-150 and a pickup truck? That's cosine, they're algorithms, cosine, dot product. It's very simple. Okay, things we probably learn in linear algebra.
ASCII,
So
ASCII.
nothing there, nothing special there. That is semantic. But here's the problem, and I'm going to show you an example. I'm going to give you a real example of customer data. They allowed me to show you, so don't worry. I just can't tell you their name, of where semantic fails miserably. Okay? So it sounds cool, right? When I tell you pickup truck and I give you a 1500, a Toyota Tundra, I give you all the permutations. But also think about, what if that sounds perfect? When would we not do that? Okay, we'll show you a scenario where that miserably fits.
ASCII,
Okay,
ASCII,
to go answer that question that we had, now you know that we have numbers. Now,
ASCII,
we also have a large language model. Right? So a large language model is the thing that generates this
ASCII, ASCII,
representation. What we did here is we asked a question. We found the answer to the question in Elasticsearch vector database. We took that answer and we sent it to the OpenAI model to say, respond to Sunile here in a human format. I don't want the damn link. I don't want the document ID. I want the answer. And the only thing that'll give me the answer is a large language model, ChatGPT.
ASCII, ASCII.
Okay? The two models, you're on the money.
So do the models have to be like well paired? Like are they interchangeable essentially? Like do they all speak the same matrix?
The vector model, the data that you, when you bring data into a vector database, the model that you choose must be the same model you use when you ask the question, because the math. So I'll give you one example. The math is going to be different. Okay, if I was a part of the team with Cambridge, right? That we open sourced the model Silver Retriever. If you say Batman or Superman,
ASCII,
if
ASCII.
you go back here and you ask, if you do something like this, Batman or Superman, or the numbers are going to be completely different.
ASCII,
The
ASCII.
reason why is a model is very opinionated. Model developers, it's like painting. Okay, with let me give you one very easy example of why this matters. This should hopefully hit home.
ASCII, ASCII, ASCII.
This is
ASCII.
how the lead data scientist at Cambridge explained to me, because I was a little confused. I didn't understand it. So I basically stole this from him. Not this slide, I built it, but he explained it in different ways, and this is what came to my mind. If I tell you this is painting of Martin Luther King at the same point in time by three unbelievable artists. Right? I'm a big fan of Dan Wilson, but Dan Wilson, Suzanne Steins, and Derek Russell, his paintings are all over my bathroom. My wife loves his painting. Now, if I asked you, what is the best painting? What would you say? We would all have a different opinion. And if you ask my wife, if I want to put a Dan Wilson painting in the bathroom, she's like, no, that's weird. It feels like it's too realistic. You need pastels in the bathroom. It's based on the use case. So a vector model is very similar. When you look at the vector model that I was a part of versus OpenAI versus Gemini versus any others, we all our numbers are going to be different because it's a representation of those authors. The world's, it's a representation of the world in the author's opinion. The author is a data scientist. I'm not a data scientist. I'm just curious, right? But that's all it is. So to answer your question, the data that comes in, you use a model, that question you ask has to use the same model. We're using the same painting, the same strokes.
So if you wanted to move to a newer model, you would have to re-vectorize all of your data sources?
So if you decide that that's a good question. So in Elastic, I don't know the other vector database, okay? But in Elastic, when you vectorize data, you have the choice of vectorizing the data in multiple ways. So in fact, that's kind of what I did actually in that demonstration here. Let me show you. In this scenario, when I asked a question of our data, I actually have two models. I have the Azure 88002 model, and I have another model called ELSER. So when I ask a question, I've actually vectorized it twice. Why? Because some models do a better job. Some models do a better job than others. So in Elastic, we don't make you pay for that. We basically say, you know what? You may decide that a single field may be vectorized multiple ways. But let's say that data is already in Elastic and you decide that you need, I'm sorry about this, let me turn this off. You may decide that you like a new model, then you re-index the data using your model. So you can one field can be vectorized many different ways. Best way I can say it. Now, this model up here, right here, this model up here, the chat model, the completion model, that could be anything. The model up here, OpenAI, that is the completions model. That is the model that generates the answer. That can be anything. It's not tightly coupled. Vectorization is tightly coupled. The answer generation could be any model of your choice. All right. Showed you playground. Let me talk to you about a challenge within the space. Am I doing on time?
Whatever you like, Sunile, it's fine.
Okay.
Yeah, when folks start leaving, then that is time to start wrapping it up.
Okay. You want to go? I'll go.
You're good.
So one of the challenges of large language models is it only has so much capacity in terms of its understanding. Let me give you a very clear example of this, okay? Gemini announced that they're going to do a 1 million token limit. Someone here was asking about tokens. Let me tell you, so what does that mean? When you give a large language model data, there's a limit. Think about us as humans. I mean, this is a lot to take in, what I'm telling you. Right? You're probably overloaded, like, what the hell? The large language model is the same exact way. The more information you give it, it's like, wow, this is a lot to take in. So Gemini recently announced that they're going to offer a 1 million token limit. So the knee-jerk reaction, I went to Bangalore, and the engineers at Bangalore were like, Sunil, why do one of the challenges is when you send data to a large language model, it can only take so much. Gemini said you can give it all the data you want. Let me explain why that's a problem. Think about it. The moment you start treating a large language model as a child, things will start to become very clear, in my opinion. So I have 3 kids. My daughter recently read the book Harry Potter, Sorcerer's Stone. Now, I asked her a question, and I said, honey, you cannot open the book. I just want to see how much you can remember. And I asked her a question about the book, and she used abductive, deductive, and inductive reasoning to come up with the answer, also known as hallucination. Okay? She made shit up. Now, why? Now, the reason why is because there's so much in her mind, right? So she just, all the attention activations went off, and some of it was true, but some of it was just, I don't know how she connected the dots. It was overload. Now I told my daughter, okay, let's reset. She was frustrated that she got it wrong. So I said, honey, the answer is right here in this page. Actually, it's in this paragraph. She got the answer right. So there's a study about children and being very direct with them and intentional with them and saying, okay, open book, nobody likes open book, but if you tell a child, if I can tell you where the answer is, even though they may not have the full context, and you give them a
Asking-
question, if you tell them where to find the answer, even though it doesn't have the full context, their reasoning level goes up 97%. The large language model is exactly the same. If you think that a large language model with a 1,000,000 token limit, and if you give it the book Harry Potter, and then you say, answer this question, guess what the model's gonna do? Abductive, deductive, and inductive reasoning, and make shit up. So be careful with that. Yes.
asking,
And how do we know about the accuracy of the answer or reliability of the answer, especially when we start touching medical field and things that are
asking,
important to other people, not just to my knowledge of Harry Potter?
Yep.
Uh,
That's very good. Okay, good. So the question was, how do you know that there's accuracy to this answer? So especially in the medical field, I totally understand it. Finance is a big one, right? They're asking questions and they're like Home Depot is reporting their financials, and a lot of it is through based on conversation possibly. So how do you make sure there's accuracy? So in the world of LLM, first of all, humans are not perfect. Neither are models. So start to setting
asking,
the bar of perfection to a model. Let's first us get there. Okay, we're not. I mean, there's a reason why the SEC exists. It's because humans fuck up. I screw up all the time, right? So models are going to screw up. Humans screw up. So setting the bar of perfection, impossible. Humans can't reach it. Models can't reach it. Let's set there. But how do we humans come up with
Asking-
accuracy?
asking,
Citations. How did you come up with your answer, Sunil? Where did you get your answer from? Adara, my daughter. And she goes, Daddy, I got it from here. Citations. Cite your damn work. Okay. So this is in an agentic workflow. When a model answers the question, you
asking,
have to make sure that it cites the work. And it is then still ultimately your responsibility, even though the burden of reasoning and finding the answer has shifted to the large language model. Ultimately, it's your job. If you're responding to your CEO or CIO, your director with an answer, you still have to make sure. Like, remember the attorney about a year ago, they said they got fired because they went to court with data from ChatGPT. There was no citations, right? What an idiot for doing that. How can an attorney, the people that have all the paralegals on the planet and they couldn't cite their work before they went to court? That's ridiculous. That's their fault. I wouldn't fault the large language model. So
asking,
in order to answer a question correctly, like for example, when the doctor walks into medical Memorial Hermann and says, Sunil's here, tell me the medical conditions quickly because I have an ER room. It
Asking-
should say Sunil has a history of X, Y, and Z, and here's a citation of date, da, da, da. Now the doctor is ultimately responsible. If they don't believe the data, they can go and inject and say, tell me more.
asking,
So these are things called agentic workflows. It's called chain of thought. So you can pin models against each other. There's a really good article by someone that writes an entire blog post. He tells a OpenAI to write a blog post about AI. And then he tells the large language model, hey, I just wrote a blog. He didn't. Can you review this? And the other large language model reviews this and says, oh, there's a bunch of stuff in here that has not been cited, is not accurate. And then he takes that and sends it back to the original model as if he autocorrected. He's just pinning it. It's called chain of thought. So there's ways around it, but ultimately the burden of truth is still on us. The burden of reasoning has gone to the model. Good?
asking,
Oh, maybe you wanted me to say yes, you'll get a perfect answer. I can't say that.
Well, I'm just, my mind is expanding on like, if it's an urgent situation and the doctor does not have the time to go and verify the answer.
Yep.
It seems like he could be set up for a failure in those moments. And how is that usable if I know I have to verify?
Yeah. So it is no different when the doctor is looking at a chart today and interprets it incorrectly. The chances of that and the model with citations are going to be pretty darn close. Right?
But your question is a very good one. The burden now that we have LLM models working so well has shifted to what is known as eval in industry, evaluation, and verifying whether model is hallucinating, is slightly or totally in the left field. And that, how do you do that automatically? is where a lot of research is happening now.
ASCII,
It's a great question.
It is, but you're right, like
You ask it for citations.
you can ask
You could ask the same question slightly differently and compare the answers. And you could use two different models and ask the question and compare the answers.
100%. So I'm working with a Canadian customer of pharmaceutical that is basically like CVS of Canada, where a customer goes, "Oh, a doctor gave me this. Oh, by the way, I'm taking this other medication. Can I take this?" Right? So they're using Elastic to go power that. The burden is still on the the pharmacist to validate that answer. We're not taking that away, but the research behind the citation, they're using the AI to help them accelerate. So
ASCII,
we're not taking the human out of the loop and saying you can just trust what the large language model says. There is, what he's talking about is deep eval or RAGIS. There's frameworks out there today that allow you to determine how far away from truth is this large language model going. Right? It's called deep eval and RAGIS, and that's already baked into the agentic workflow. But even if you do RAGIS and deep eval, you cannot rely 100% for accuracy when people's lives or financial, you can't do that. You still, the burden of truth, it still comes to the individual. Okay?
Trust but verify.
Trust but verify. Security, you must have a security background. Yes.
Just a quick question on LLM. Which LLM are you guys using for Elasticsearch?
ASCII,
We connect to, we integrate with all the LLMs at the moment, the most popular ones, like Bedrock, Gemini, Azure, OpenAI, IBM Watson, basically everything. We have two embedding models. We have ELSER, which we haven't talked about. Maybe we'll get to that today. It's a really cool article, a really interesting model that Stanford talked about. We'll talk about the NLP from Stanford. And then we also adopted E5, which is actually a Microsoft model. It's a multilingual model. So multilingual model is like, let's say data's in English. You can ask questions in Hindi, or data's in Hindi and you can ask questions in Spanish. So those are two models we support. You might be asking about the completions one, which is the generative AI one. We don't have one. We will be adopting one, and more than likely,
ASCII,
we don't have an NDA, so I can't say that. So again, I'm not from the customer, but we are going to be adopting. We are going to be putting a lot of our customers appreciate our openness to integrate with the large language model of your choice. But a lot of our customers are like, look, you just made all of this easy, right? You would have the models. Can you just give me a generative model? So we will be giving you a generative model probably in the March timeframe.
ASCII,
But we
ASCII,
integrate with OpenAI and all that. Yep.
How do these models deal with bias or noise within the models?
Okay, so my role at the model building for Silver Retriever was biasness. So I'll tell you one example. When I first got engaged in building a model, when you said construction worker, the affinity to a male was 30 times higher than a female. The model just said, oh, construction worker is a male, period. And so I had to work on giving it. So what was interesting is that I had to give it many examples of where females work in the construction space. And the hope was that if you give it more examples, that it would then say, oh, the proximity of construction worker to a particular gender is nearly equal. Okay. So it takes time to train it out, but I'll be honest with you. Remember I told you once you start thinking about large language models as a child, you know, talking about anything, about getting rid of biasness and anything, start early with training with your children, start early training with your models. And the more representations you have, the better it is. But I'll be honest with you, humans are biased. I'm working with one of the largest banks. I went to New Delhi. It was the most ridiculous conversation. They said they don't want to use large language models because they're biased. And my CEO was sitting next to me. I shouldn't say this out loud. My CEO was sitting next to me, but I didn't want to interject. I said, why, you know, I wanted to ask the question, but I didn't. And so I asked it a different way. But I was going to tell you what really was on my mind. When are you going to remove biasness from every single person at the bank? Not. But that would have been a bad question to ask. But I'm like, so I did, and I shut my mouth. I asked it politically correct, but it's bullshit. It's BS, right? To expect a model to be perfect, yet humans are freaking flawed as hell. And all of a sudden we're asking machines to be perfect is bullshit. So we have to be practical.
That's exactly what the point I was going to make. Why would you try to train the model? Because with all honesty, we all know this, biased or not, this is not about genderism or sexism. Most constructions workers are male.
ASCII,
And I think that's okay. I don't know if that's necessarily a representation of a bias. It's just sometimes.
They ask for the statistics though.
Yeah,
Show me the statistics on, if
Yep.
you're worried about sex, show me statistics on sex in this occupation.
yeah.
Or show me the statistics on age, or, you know.
Let me explain. There was a little bit, she's actually on the money on this. She's actually right. So some of it is political, I'm not gonna get into. But the piece that she's on the money on, like, when you think about construction worker, you do think most of the job in terms of quantity of workers is probably male. So some of that bias is actually real. But why does this matter? So the reason why Cambridge data scientists wanted to remove biases, one example is construction worker, is that if you ask a large language model, it doesn't know if you're female or male. When you ask a question, can you tell me what jobs, I'm 150 pounds or I'm 130 pounds, what jobs can I do as a construction worker? The response was always incredibly physical labor work. It didn't even consider females and what they could account for. So that's why we wanted to eliminate the bias. It's not because we trying to be politically correct. We wanted to make sure that when someone doesn't give us a gender, that we give the equal opportunity for the large language model to say, you know what, there's a lot of other jobs that maybe 130-pound female or male, doesn't really matter. Maybe we need to offer a different type of job description, others that are available. That was the challenge. That's why we tried to remove biases. Okay, it was not politically motivated, at least with this team. Any other questions?
You know, I have a sort of an off-topic question. I'm not sure if you have more slides.
This is your session. I'll talk any direction you want.
So I'm sure most of us heard about DeepSeek.
Yeah.
It's an open source. It's now available. Anybody in the US can download and play with it. Yeah, I know AMD is already, well, in fact, AMD was already testing it from January 10th or something, based on what I've read, before, you know, it became a common use and shook the market. So do you, I mean, what are your thoughts, and if this is something that you would be open to trying out?
So Elastic is already talking DeepSeek, right? So if that's what you're asking, we've been talking to them for a while.
Okay.
So they in fact are very interested in, and careful, we're in the open forum. So they're very interested in what we're doing and how we do what we do. So what they're doing very much complements it. What's interesting about everything they did is limited amount of time, limited amount of resources, and how they did it's phenomenal, right? And so, but the reality is they still need a reasoning layer of data that a vector database provides. And how we do it, we haven't talked about this, but we've talked about vectors a lot. We haven't talked about hybrid at all, but this is why they're very interested in how we do it. We can feed their neural layers on more reasoning about, so they claim that they build knowledge graphs in the mid layers of the feed forwards real time. That's their claim. And what we are doing is we are going to enable a vector database to feed those layers real time. They want those certain chunks. We're supposed to talk about that. Those chunks need to feed those neural network layers within just, you know, like a JIT compiler. They're looking at JIT compiling for the neural network layer, that when you ask a question, real time, we feed the chunks. So it's very complementary.
ASCII.
I know what's going on with that's recent.
Yeah, that's recent.
Very recent, yeah.
NVIDIA is down like 20%.
Yeah. Well, they changed it, right? Because
Video.
yeah, but they changed everything because they're doing it cheaper, faster, and you know the amount of money they spent is significantly less. So it's a threat to NVIDIA, but to us, we find it as a complementary, because as the cost of doing large language model computing decreases, more adoption will happen naturally because it's just less money out of your pocket.
And I hear nothing but good things about DeepSeek. Even Satya Nadella, all these big tech entrepreneurs are, you know, raving about it.
We've been talking to them for many months, but we couldn't do it openly because they were very touched on. It was really cool to see them. Were you gonna ask?
So I got two questions. The first one's really easy. The second one's a little more in depth. The first one, you mentioned, like, when you're listing out all the like models that it can tie into, you just really briefly went past like Bedrock and then kept going. does that mean that it'll tie in with like for all those different services, any of the LLMs that if those services support will also like automatically be supported? So as Bedrock adds new models behind the scenes, or as Microsoft adds new models behind the scenes, those will automatically get Elasticsearch integration.
The lowest common denominator is that framework, so it's very easy to integrate with it.
Okay.
So yeah, if tomorrow they decide to enable another model, we're using Bedrock's framework for completion. That's the beauty about Azure OpenAI, is that they have an SDK, and I don't care what powers it, 4.0 or the crappy 3.5 turbo. We really don't care. It's a single spec.
Okay.
So it's very easy. It's a little, now IBM Watson is a little more complicated, but we did adopt them because there's a lot of enterprises using it. But you're on the money there. It just made it easy for us to integrate.
The second question is a lot more completely different direction, a lot more in depth. As new technology comes around, it often causes societal shifts and the way people think about problems. And one of the things that caught my attention is when you were showing at the very beginning where you can ask a question, it'll jump right to the moment in the video where it answers the question. To me, that it's kind of stripping context at that point, because you can jump directly to a snippet that answers a very specific question, but you lose all the context around that. And AIs and LLMs as a whole tend to have that kind of effect. What kind of research is being done, and is Elasticsearch doing any research of its own around kind of some of the ramifications societally and how that can shift the way people actually use the information?
So what we are looking from a society perspective, not a lot. Okay, I'll be honest with you. But what you recognize, it's very important that when you, like in that video, it pointed right to where the answer was, but it's losing context. And in fact, that context, if you put it in together, may not have answered it accurately. Like you may have walked away thinking the answer's right, but if you step back 2 or 3 minutes, he or she was talking about something totally different. And that leukemia one, that was pretty simple, right? But I totally understand what you're saying. So what we do in Elastic is we have something, we use rank evaluations framework, where in isolation, when you have an answer to a question, that looks pretty, right? But when you look at what you need to do is take a step back and look at all the context around it and rank that. So we have something called unsupervised re-ranking. It's called a cross-encoder model. And the cross-encoder model basically says, I'm going to take these chunks. If we have time for the demo, I'll show it. I was going to, but this is a good conversation. What it does is it steps back and takes a look at the context and then re-ranks that. That's what we're doing at a technology level, but not at a society. Okay, we recognize that you are on the money on that. But if you don't have the context, you may be walking away with the wrong answer. We have to step back and re-rank those chunks. We haven't talked about chunks, but the chunks are basically portions of the larger data set, because the large language model, remember the brain, big brain, it can't take in all of it. So we chunk the data. And then when we find the chunk, we, like he said, try with that context may not be within it. So we take a step back and say, what else is around it? By the way, I wrote an article on this. It's on Search Labs. It's called Fetch Surrounding Chunks. If you Google it, it will probably be the first or second article on Google, Fetch Surrounding Chunks. And you see that I acknowledge that if you look at, in fact, I did a test with Harry Potter, and I said, what is the Nimbus 2000? And it found the Nimbus 2000, but it didn't really answer the question. And in fact, it said that it breaks and it made up some answer, but it was because that chunk didn't have the information. So what I did is I said, oh, maybe I should be looking at the chunks around it, the entire context. And that's when we found the answer to what is the Nimbus 2000.
Asking, can I feed these models in real time the real answer or the right answer? If I know this answer here is incorrect, I don't think you can do that with chat GPT, but can we do that with yours?
So give me an example. Like when you say there's a wrong answer.
Let's say I say, what colors does Superman wear? We know it's blue and red. Let's say it says black and yellow.
Yeah, thinks it's goblin.
Right? Can I give it the answer in real time? Because I know that's the right answer. Or we can't. Or is it you guys have to train it in the back end?
Okay, so that's actually good. So remember, when I asked the question earlier, remember that demo I was showing you earlier where I asked the question about which members dissented? It
Ask-
answered. It answered because I took that document, the FOMC meeting notes, and I threw it into an Elasticsearch vector database. We found where the citation is for who dissented, and then we sent that paragraph to the large language model, and it only used that as the grounding truth to answer the question. So in your scenario, if you say, what color does Superman wear? What colors does Superman wear? There's a problem. I mean, they mostly all know, but let's just say that some immature model says green and black. Well, the way to overcome that is not real, because first of all, ask it for citations. That's one thing. Like, okay, it's green and black. Where did you get this from? And it's gonna say the Green Goblin. Like, dude, you're wrong. Spider-Man, right? You're in the wrong universe. So this is where citations matter, back to her question. But the way to overcome that is using a vector database. Ask the same question. What colors does Superman wear? We will go find the answer in a vector database where Superman wears the following colors. We give that to the large language model, and the large language model will say he wears blue and red. So don't rely. This is why RAG, retrieval augmented generation, is very important, because you're grounding the truth to the large language model. You're not allowing it to hallucinate, even though hallucination is still a possibility based on the temperature rating. We haven't talked about that, but if anyone's interested, I can tell you what temperature is in the model. But basically, as long as the temperature rating is at a minimum, at a medium, it will say, hey, based on the content you gave me, this is the answer.
Completely shifting topics again. As you vectorize this data, it looks like there's an explosion in the size of the data. If you had like, let's say I had a 10 gig repository of all my company's documentation, and I want to go vectorize that for my customer service team to use. What kind of shift are we talking about in terms of database size for?
Now we're getting into the stuff. All right. All right. Oh, do you mind if I just show this for a second for everyone, just so they understand a vector space? I promise I talked about this, and I'm going to hit your question. By the way, those of you that want to know what a vector is, why does vectors matter? So, and I'm going to get to yours in a second. Yours is on the money. Think of this as a vector space. It's all the data. Okay, and now, so it's very hard to see. The folks online maybe can see better, but this is all food. This is weather. This is animals, and this is occupation. Now, when you ask a question, a professional occupation, let's say, DJ. I don't know why that came up in my head, but DJ, where do you think it would go in the graph? Probably somewhere right here. Professionals. It wouldn't go by food, right? That's what this is. It's basically objects, and then you ask a question and you grab the nearest objects. So the easiest way to explain this, bear with me, I know you know this, but I'm gonna just share. So if I have a vector space, this is a very silly two-dimensional vector space. Okay? Now, if I want to find something in a vector space, let's say hospital, chips, and pet. Hospital would be right there. Chips would be right there. Pet would be right there. It's not pet, is it? It is. That's why it's a little bit far apart, right? That's why the vector space, whoever's crazy enough to have a pet, the snake, it's a little, cats and dogs are normal, right? That's why the distance between cat and dog and pet is super close. And that's why snake is out here, even though it could be a pet, it's a little bit further apart. Are you with me? That's vectors. I know. But these are numbers. These are not, doctor would be converted into that that number that I showed you. So why does that number matter? So this is a number, this is a number, this is a number. Now all I need to do, check the distance between these two numbers using cosine or dot product or Max inner product or Euclidean. Right? That's a different conversation about why, when, and where, but that's a vector. This is how we do it from a math perspective. Is there a question about this? Yeah.
Yes. So then how do you deal with words that are in different categories? Like orange could be a color and it could be fruit.
A model. Okay. Orange could be a color. Orange could be a fruit. Is there a fruit? It is a fruit, right? So in a vector space. So by the way, there's a really good book called Natural Language Processing. And I forgot the author's name. It's a great audiobook. He's a monotone, by the way, so it's a little boring, but it explains a really good concepts. And one of the things he talks about is bag of words. Okay?
ASCII,
And bag of words was the origination of vectors. Okay, bag of words was like, you just have a sentence, throw it in a bag, jumble it up, grab one and put a number associated with that. And orange would maybe be one of those words. Now, what sucked about that is it could be the color or it should be the fruit. So you're totally screwed in context. So why transformers was interesting? Because, by the way, anyone may have heard of word to vect, right? By Google, word to vect was a really popular one. The reason why that was cool is because, again, it took a word, it turned it into a vector, and we were good. His example is on the money. He's saying, what if there was orange? Where do you put this crap? Well, that's where it failed. So that's where transformer model. Remember,
ASCII.
attention is all you need. Well, now, watch this. I love eating oranges.
ASCII, ASCII,
In this context, what is orange?
ASCII,
Because
ASCII.
the context around it, the attention activation, it doesn't look at just orange. It looks at the context around it. So when you go to the feed forward network in the transformer, I have a whole slide I did at a keynote I can share with you. But basically what it does is when you have a sentence in a transformer network, it puts a weight associated with each word. I love to eat oranges. And there's some words like meaningless. Doesn't really matter. Love, okay, puts a weight associated with it. And basically it looks at certain words that may have meaning and it puts a weight associated with it. And then it goes through the next layers of understanding, like, what could this mean? What could you replace it with? And if you can replace oranges with apples, that's a
ASCII.
fruit.
ASCII, ASCII, ASCII.
Starts to reason, like, if I replace this word with this word, love, hate, oh, that's, it's a feeling. Right? So that's how it does the reasoning layer. It's really incredible. So why does a vector model do a good job? Because it doesn't look at just the word itself. Word to vect does, and it's crappy. The transformer model does not. It looks at context. Yes.
In that case, in your example of asking specifically using the word descent, if you used a different word, what would
ASCII,
happen?
So what
ASCII,
is another word for dissent? I'm a little tired.
Disagree.
Disagree. Thank you. So let's say that this was a vector space. We would have disagree and dissent and whatever. Okay. And what we do is when we go into the transformer model, it maps that here and it will find that, look, even though dissent may not have been in the vocabulary of the meeting notes, it did find that they may have said disagree. This particular member of the FOMC disagreed with the stance of he or she's counterparts. And so we find a similarity, and then that's how we do it. That's why it's called semantic search. We are interpreting your question. It doesn't need to be exact. For F-150, you're precise. When I say pickup truck, F-150, 1500, Hummer EV, you know what?
ASCII,
Oh, to answer your question about, okay, so he brought up an important point. It's a little techie, but we're at a tech meetup, right? So this is cool. This is very expensive to run. Okay, let's be really truthful about this. So let me explain the problem with a vector space. I shared it with you already, darn it. Okay, you know what this is. Does anyone know what this is? You may have already seen the slide.
ASCII,
My fault. Okay, sorry about that. Okay, so in memory, so those numbers that we've been talking about, those numbers, guess where those numbers need to reside when we do the computation? Remember I just showed you pet and snake and dog and cat? Well, all of that computation, all those vectors are in memory. For those of you that are technical, and I don't know your background, but it's RAM, right? Our machines only have so much. And the data's on disk. So let's say that you have billions. By the way, I work with we work at billions of scales at Elastic, right? So nobody comes to me with a cube. I have not heard anyone come to me saying, Sunile, I have 50 vectors. Everything is like 50 million to a billion to a trillion vectors. That's the scale we work at Elastic. We just don't get the cute science projects, unfortunately. So when somebody says I have 1 billion vectors, well, guess what? Those 1 billion vectors are on disk. And then when you ask a question, we bring them into memory. Now, can you imagine how much memory it takes? Now, let me just give you one example. 500,000 documents. And let's say the document has only one field that's vectorized. A document, multiple fields, right? A document is basically a JSON document. It can have first name, last name, address, occupation. That's a document. And then let's say one of the fields in the document is something that you decided to vectorize. And let's say that vectorization, the dimensions is 1,000. Okay. It would be 2 gigs of RAM. That's a very small data set for small dimensionality. That's a lot of memory. So it is very expensive to run this. So this is the problem. This is Mona Lisa. Let me explain how we overcome this challenge. Mona Lisa, the beautiful Mona Lisas on your left-hand side. This is what a model gives you out of the box, a float. Every dimension is a float, okay? And it's full fidelity. But in computer science, we are able to decrease and go from float, and we can go down to an indate. Less memory requirements in RAM, but you lose a little bit. You see, lose a little bit of the lake back here, and then we can actually go down to an int4, and then you kind of lose it, and and that's binary. Okay, it's called binary vectors.
So we're running out of time.
Okay.
So
You want me to finish up here? This last?
what do you reckon?
Yes.
Yes,
Okay.
please.
Let's talk about quantization, and then we'll end it.
Yeah.
Thank
you.
So in vectors, most people are using int8, int4, and float. Most people have gone down to int4 now because this takes up 8 times less memory. But what's very interesting is if you convert the float to a binary, 32 times less memory. So remember I told you 500,000 documents with 1,000 dimensions, 2 gigs. With binary, 64 megabytes. Huge difference. So Elastic offers this called BBQ. It's based on a research paper. I forgot the individual in China, but he called it Rabbit Q. About 2 years ago, nobody paid attention to him. There's an individual on our engineering team. His name is Benjamin Trent. He's phenomenal. He said, I think this will be the future of binary quantization. And why? Because he said, and we wanted to test it, the problem with going from here to here is that you lose a lot of precision. You lose a lot of, like, look, Mona Lisa, all the beautiful characteristics of Mona Lisa are just simply not there. But how we do it, we're able to now ask questions and keep precision at 97%. Okay, there's a way we do it. There's an algorithm behind it. I ran out of time today, so I appreciate it. But this is important. So yes, vectors are important to, very expensive to run, but the way you decrease your cost is quantization.
Okay, so does that work for the storage cost too? Like as you vectorize your document store, does that also work on the storage backend as well?
Yeah, right. Because we in Elasticsearch we do something called auto quantization. So a lot of vector databases require you to go do this on your side, the Python side. They ask you to write this crap code that goes from here to here to here to here. You can do that. You have the right to do that. In Elastic, you just send us this, and we will automatically convert it to your choice. So it saves you memory and disk space. Yep, on money.
Right. I'm pulling the shepherd's crook. Did anyone learn something? Yes. Many thank you. Yes. Thanks everybody. That was great. And well, we need to wrap it. Thank you all for coming out. We do have a session next month, and I'm already blanking. It's on our meetup. We've got it booked to be here second Tuesday of each month. Thanks for coming out. Please take some pizza and drinks if there's any left. Please take it, and we hope to see you at another event